All right, this is the first example of chapter 8.3, time dilation. So the first example is question 154. Let me read the question. Question 154. How fast must a vehicle travel for 1 second of time measured on a passenger's watch in the vehicle to differ by 1% for an observer measuring it from the ground outside? So we have a vehicle moving at a certain speed and we have someone outside measuring the time it takes for a certain event to happen. We are told that from the point of view of someone inside the vehicle, the time elapsed is 1 second. Now remember the example I gave, or the trick I gave in the previous video. The person at rest, measuring at rest, always have a longer time. So the person at rest here will measure the time delta t2. So the time elapsed equal to delta t2. So the 1 second as measured by the passenger inside the plane has to be our delta t1 in this case. Now they differ by 1%. There's two ways to see this. Delta t2 could be equal to 0.99 multiplied by delta t1, or it could be equal to 1.01 multiplied by delta t1. But here's the thing. Gamma, the relativity factor, is always greater or equal than 1. So that means there's no way for delta t2 to be shorter than delta t1. So this one does not make any sense. Let's write that off. So that means delta t2 has to equal 1.01. So now to solve that problem, we're looking at the velocity. We have this formula. We have our delta time 1, delta t2 over here. We plug them into the formula. Basically, we take delta t1, flip it on that side. We got gamma is equal to the relativistic factor equal to delta t2 divided by delta t1. So we replace by the numerical value, so 1.01 divided by 1 in this case. So this will be our gamma factor, by the way. Now, we need to extract the velocity over here, and this is only one formula. There's quite a couple of algebra steps here. I'm not going to do it, but the end point is we will get that formula over here. So the velocity is equal to square root of 1 minus 1.01 divided by 1, and this term square, we get 0.14 c, or 14% the speed of light. All right, so the main challenge here is to in identifying correctly which one will be the time from the point of view of the moving frame or someone inside the moving frame, and the time from the point of view of someone in the rest frame. All right, but beside this, it's one formula, one unknown. It's simple algebra trick at this point. All right, so see you in the next video for another example.